Welcome to another episode of the dOrg Hot Seat. Today we have Nader from EigenCloud, and this is an episode that I've been kind of waiting and hoping that we would have, because since the beginning, eigenlayer was sort of like this new primitive that came into Web3. You got economic security, and then you got reusing that economic security for more stuff. Potentially like anything that you want, right? And turns out that it took a while for this to really get the party started. And now we've seen EigenCloud coming in and offering already all of these AVSs, or sort of like already products on top of EigenLayer that are from the same foundation. Is that a good understanding of how EigenCloud came to be?
Yeah, I mean, I think that essentially over time, as the product offering has kind of matured, we've kind of layered on abstractions, and we continue to kind of build up the stack. And I think in general, one of the things that we've learned and that we've really focused on is that we can't expect people to understand what to build or to prove that what they can build is possible if we're not dogfooding and building things ourselves. So we've kind of doubled down on continuing to build out ourselves as well as support other people.
Right on, exactly. So I guess you front run my next question, which was there was this the EigenLayer as sort of like the platform or the infrastructure to build your own security, and now it's like sort of building upwards onto like, hey, this is the stuff that you really can do on EigenLayer.
Yeah, exactly. Yeah.
How did these three verticals, AI, compute, data availability, which I'm not mistaken was kind of like the original one, how did these came to be? Why those specific verticals?
Well, you have essentially two main like pieces, I would say, of EigenLayer. You have the EigenLayer protocol, and then you have EigenCloud. The EigenLayer protocol is open for anyone to build. Recently, Layer 0 has gone live. Recently, Infura has gone live. Redstone, one of the top oracles in the crypto space, is live. There's a lot of different variety of different product offerings that we're continuing to support. But one of the things that we're focused on is essentially building out products that we think should exist, that we think that we can build better than anyone else. And also we're focused on revenue. How can we actually bring in like more and a lot of revenue to make our product offering, our protocol, our token, everything a lot more valuable? So we can't rely on the protocol to just exist and have that happen. So we've decided to build out our own products based on what we've seen demand in the market for, along with what the expertise is in our company, on our engineering team, as well as the vision for, like, I would say, the founders and the leadership. So data availability was kind of our first attempt at dogfooding and proving that this design is much better than building from the ground up. So data availability is not a brand new idea. Celestia first kind of introduced it. That's a team that I worked with in the past as well. But our thesis is that the design of an AVS in terms of having the benefits of a blockchain without the constraints is a lot better than building an actual like traditional blockchain in order to actually achieve the features that kind of are necessary for data availability. And recently, actually yesterday or the day before, we just shipped 1 gigabyte per second of throughput for EigenDA, which is around 750 times more throughput than our like nearest competitor. It's just an insane amount of throughput. So we're kind of like proving that thesis is correct, because we now have like by far the most performant data availability layer. But beyond that, we were thinking, okay, what else could the market, need for developers to build out essentially decentralized applications, verifiable applications, AI applications. And when you kind of look at AWS, you have the data center at the very bottom, But the two core products that everything else are kind of built on are S3 and EC2. You have hundreds of services that are kind of in AWS, but when you actually peel back the layers, you realize that these two products are actually at the core of everything else. So, what does that kind of look like in crypto? How can we kind of essentially bring primitives to market that enable all these other things to be built, and how can we then monetize those? Well, first of all, eigencompute is kind of like essentially the same thesis and the same idea of eigenlayer. It's just 1,000x, I would say, improvement on developer experience. To build an AVS on the protocol to leverage economic security to kind of have verifiable applications built, it's pretty large task. It's a very complicated task as well. It takes sometimes teams months, 6, 8, 12 months even, depending on what they're building, to implement all these different features to go live. With eigencompute, you have essentially kind of like a different security, I would say, trade-off, but you're able to actually get verifiability for any application in just a few minutes, literally. Like if you have the application built, all you really need to do is Dockerize it if it's not already Dockerized, and then you run one command and it deploys it to our service. And you essentially have an entire verifiability guarantees out of the box, and it only takes a couple of seconds to deploy. So trusted execution environments are not like a new thing, but we believe that our approach and our design is really, really good, and we believe our developer experience is the best that's out there. So that is Eigen DA and Eigen Compute. And then finally, Eigen AI is a brand new kind of like product that no one really has done and launched in the past. And it's really verifiable AI inference, and it's also deterministic. But in order to have verifiability, you need determinism. When you kind of think of how blockchains function, anyone in the world can rebuild the history of Ethereum and re-execute every transaction that's happened, and we can all come to the exact same state. But with LLMs, you cannot do that because by nature they are non-deterministic. So one of the reasons that you can't really bring AI on chain in the past was the fact that it wasn't deterministic, but you also didn't have the verifiability aspect either. And when I say verifiability, verifying that the input that you asked for is actually what was sent to the LLM. The model that you expected to run was what was being run, and the output that came from the LLM is actually what is being served to you. So when you combine verifiability with determinism, you're able to actually bring AI inference on chain, and you're able to do a lot of stuff around, I would say, DeFi and other use cases as well.
Right, exactly. So really interesting what you said about Eigen AI. So the model itself is still the same model. There's just something that some verifiability that this is the model that received this particular input, and that is indeed the response that this model that received this input is giving. That's it comes like the response. How exactly is this achieved?
We actually have a white paper that's coming out soon, but there's also an article that was posted by Thinking Machines that's called, I think it was called Achieving, or let me pull up the name of the paper because I'm going to explain it. Okay, it was called Defeating Non-Determinism in LLM Inference. Thinking Machines was the company that was founded by the ex-OpenAI CTO, and the techniques that they kind of have used in this blog post happened to be some of the same breakthroughs and techniques that we had been building with Eigen AI as well. But the exact details of how that was accomplished will be part of a white paper that's coming out from our team in the next few days. But essentially, from what I understand, we're really taking Llama or Open Llama, I forgot which one it is, and we're taking the model that would typically be run, and we're kind of like modifying it, and then we're deploying it ourselves. And the tuning and the changes that we've done allow essentially bit level determinism.
Nice, excellent. Thank you for that. Okay, let's change a little bit and look at the other side, which is the permissionless or the provision of infrastructure. Eigenlayer was supposed to be permissionless. Well, I mean, not supposed to. Sorry, it is permissionless, and still anybody can be an operator for an AVS, given the conditions of mostly the AVS. It's quite programmable, right? How does this work for EigenCloud? Is it you guys are running it yourselves? I've seen that you've got EigenCompute, a partnership with Google. Can anybody sort of postulate and put a stake on to be an operator as well?
Yes. So anyone can become an operator, anyone can become a staker. And as a staker, you can decide where you would like your stake to be and which operators you would like to essentially be delegating your stake to. So yes, that side of it is completely permissionless. And if you're building an AVS, then you can also have any of these operators support the product that you're running on EigenLayer.
And for EigenCompute, I can be an operator of EigenCompute as well?
No, at the moment, we only have a single operator for EigenCompute, but part of the near future is making that more decentralized. And yes, we'll have EigenCompute running just like we do all the other AVSs.
Right on.
Yeah,
and the same
I
for
believe the main
AI?
part of that's going to have to do with the KMS, like the key management.
Yeah. So it's using TEs, right? So
Yes.
at least you'll have some guarantees, or you'll need to at least prove that you're running TEs, or you need to have the hardware that holds the TE, basically. Yeah. Is it
right.
the same for Eigen AI? Does it also use TEs for that verifiability?
No, it does not.
Okay. So it will be open as well, and everybody can run it.
Exactly. It's just going to be running like an AVS on operators.
Nice. Okay, that's really exciting. There's a lot of sort of hardware that's coming up now. A lot of people that want to have their own private AI compute, but it's not going to be used all of the time, especially in companies that are like continent bound. There's at least 16 hours when people might not be using it at full time. So I think there's going to be quite a bit of operator supply there on the AI.
Yeah, TEs in general has been kind of like a really cool design space for me personally to dive into, and it wasn't something that I was all that familiar with only about 6 to 8 months ago. But there's a lot of different properties that you can get out of a TE that a lot of developers want, and the trade-off in I would say developer experience versus the value propositions of getting like blockchain-like guarantees is very, very compelling to a lot of teams, and the demand has been a lot more than kind of I expected to see, and a lot of people also kind of already understand all of this. But I think and where what we're building has come in to play in terms of people wanting to use it has been a lot of people try to build this sort of product and maintain it themselves, and they realize it's a lot of work. So being able to just go download our CLI and like run a couple of commands and have it call like kind of all managed for you has been really, really one of the biggest value props. Like combining the guarantees that we offer with the developer experience together in a simple package, and you know, charging whatever a month for it is a lot less expensive than trying to pay an engineer, DevOps people to kind of do all this stuff on your own. And then on top of that, the verifiability aspect of it is something that is really, really also hard to, I would say, build on your own.
Funny that you mentioned TEs, because yeah, Niraj has asked a question in the chat. Let me invite him to speak. There we go.
Guys, yeah, so I have a question for you. Why Eigen Compute chose TE over MPC or some other kind of verifiable computation method?
To my understanding, we've investigated pretty much everything that you can possibly imagine under the sun, because that's kind of the whole value prop of EigenLayer is verifiable compute. So this is something that Suram and G and all the different engineers on our team have been really diving into for years now at this point. And based on all of the different trade-offs that they were able to find, this seemed to be the most like overall compelling design for us to go with. Without going into any specifics, because I can't really speak for them in terms of why they didn't go with an NPC design or whatever. But I think that what we have so far has been working pretty well. So I think everyone's pretty happy with it.
I think when it becomes the centralized eigencompute, we'll run into what I think is the main problem of TEEs, which is they work well if you already trust the TEE provider. So meaning if it's running on Google Cloud, that's great because you can sort of like an SLA agreement with Google, and there's an implication that they won't look or tamper with that code. TEEs basically have been broken in many ways. There's many ways of breaking into a TEE, and when that becomes decentralized, we'll really get to prove whether those trust assumptions can hold or not. And I think this is personally this is why I'm not super bullish on TEEs in general, especially in the centralized environments. Because if you can't trust Google Cloud that they're not going to tamper with their TEEs. But then again, if you already trust Google Cloud, why do you need a TE and not a contract, a plain corporate contract with it? So, yeah, that's me and my personal
Corporate contract
sort of
in
gripe.
terms of just running your software on their server.
Yes, exactly. Like some sort of like a SLA agreement that they cannot tamper with this code, or that they can provide, or they cannot look into this code. I know it's verifiable compute, not which is less problematic than private compute or obfuscated compute inside of the TEE. I think, or keeping keys that are not tamperable inside of a TEE. For me, that's a lot more problematic than just verification. But
Well, I think
yeah.
for a TE, vulnerability has to first of all exist, and in order for someone to be able to, I would say, compromise one of these T's with Google Cloud, there are just so many layers that make it like theoretically almost impossible. Because like, let's say you are running a T in your basement, and someone comes up with some, I would say, new hack or whatever. Theoretically, the person running that can just go and like steal the funds and kind of do the hack, right? But when something like that happens and GCP is running all these pieces of hardware, their entire company and their business depends on them not allowing anything to happen. So you do have a trust assumption, but it's so hardened, like relative to almost anything else, that it's just a design trade-off. And I think with MPC, from what I understand, at least I'm not an expert here, but there's like a lot of latency issues that happen to be like introduced when you're dealing with the booting, like the boot times, as well as potentially kind of deriving the mnemonic from the different parties.
No, for sure. In an environment like Google, and I think that's mainly what I consider them sort of irrelevant, is because if you have this running in plain text in a Google server and they steal it from you, they already lose that reputation, and you don't really need a TE for that.
But can you prove that they did that?
Fair point. Yes, exactly. Yeah. But as you said, that's sort of it's the least worrying part. When it becomes the centralized is when TEs stop sort of the centralized TEs sort of lose their mojo or their reason to be, in my opinion.
Mhm.
Okay. Sort of, if what is the level of trust that an enterprise can has to place in EigenCloud itself, not EigenLayer, to sort of use it in production? What are the trust assumptions here?
Or for EigenCompute or for EigenLayer?
EigenCompute, yeah.
So EigenLayer doesn't really have anything that isn't completely verifiable, transparent, and trustless, just like a smart contract. Just like you can essentially audit a smart contract, you can audit any ADS running on EigenLayer protocol and kind of get the exact same guarantees. So that's not really your question, but I figured I'd just kind of touch on that. It's essentially just the same guarantees that you would get out of a smart contract is what you would get from EigenLayer, the protocol. With EigenCompute, we are still kind of in a beta. So I think the ultimate goal in the very near future, probably January or February of next year, is having some type of distributed KMS solution that removes any trust assumption from Eigen Labs or EigenLayer or any of the Eigen team at all. And at that point, you could kind of, I would say, consider the same trade-offs that you would from any like T product, in the sense that it's not as secure. It's not, I would say, you wouldn't trust it as much as like a smart contract, but you would trust it obviously a lot more than just a server running in something like GCP. And I think you have this like graph of verifiability versus programmability and developer experience. And at the very, very like end, most secure like of the spectrum would be just a smart contract running on Ethereum or something like that. But the problem there is like there's very low level of programmability. The next step up might be something like an EigenLayer ABS, where you have a high level of programmability and a high level of trust, but you don't really have, I would say, the developer experience of something like EigenCompute or a TEE. And then sitting, even further up from that would be something like EigenCompute, where you have slightly less trust, or I would say slightly, less secure relative to like a smart contract, but you have a lot more programmability and you have a lot more ease of use and a lot better developer experience. So you probably wouldn't put $1 billion in a TE, right? But you would use a TE for what it's good for. And I think that's the whole idea. You kind of like understand these different security trade-offs and you use the product for what it's best at. And over time, we're going to introduce more and more security guarantees for EigenCompute. And ultimately, we would like to kind of match what EigenLayer has, or maybe what a smart contract has, by running economic security as well behind the TE. So then you're not having to really trust anyone or anything with any type of funds, because then you have slashing and redistribution. That's part of the product. So if something gets compromised, then the compromised party can actually recoup those funds. And that's kind of where we're headed. But that's going to take some time, that'll be probably later on with the life cycle of EigenCompute.
I see. What are you excited for people to build on EigenCloud?
I think games are really interesting because you can run pretty much anything and bring the results on chain. And that's been really, really obviously challenging to do, because you can't really do that with a smart contract. You can't run this crazy complex systems within a smart contract. So we just did actually a collaboration, or I would say launch announcement with a team called OpenFront, or a game called OpenFront. And OpenFront has around 650,000 monthly active users. And one of the things that the founder has always wanted to do would be to run these tournaments online where people can play against each other. But since he's not like Ubisoft or one of these massive companies that can actually, have the trust of the fact that the software that's running is what is being said that's being run, is kind of like he's kind of almost like an indie developer, even though they have a lot of users. There was no trust in order to kind of like have an actual real tournament that someone wasn't cheating or running like different software than they were supposed to be running. So we decided to deploy OpenFront and a TE, and we put like $1,000 up, and we played in a game, and we were able to bring the results on chain, and the winner like was able to take that money. So building out like really simple, like easy to deploy games like this and allowing that type of mechanism is really cool for indie developers. And if you can build something that goes viral as an indie developer, you can kind of maybe get distribution by having this as a differentiator. And then AI and AI agents obviously are kind of like probably our biggest focus. Being able to kind of like have agents that are running where you can verify the code that's being run, you can verify that hasn't been tampered with, you can verify that no one has access to the mnemonic that's being run within the TE, that only that agent can actually spend those funds. You can build out really, really interesting, applications and agents. So I think AI and AI agents are probably our number one. Gaming is right up there, but really being able to kind of add verifiability to any software is kind of like a big unlock that I think is still not really been cracked in terms of like seeing through the whole value proposition. And that's kind of been the original, like, I would say, inspiration for EigenLayer in the first place. It's just that the EigenLayer ABS design is just a lot more challenging to bring to mainnet. So the barrier to entry has been higher. Eigen Compute, the barrier to entry is just like way lower.
Yeah. It seems like there's a lot of like the design space is sort of quite broad and quite generic, especially for Eigen Compute. Anything that you can Dockerize, you can just basically run it in there. So if at dOrg we are a builder community, we help companies or we help developers, we help teams bring their projects to life. And if we were to help anybody to bring their project to life using Eigen Compute or Eigen AI, something with AI agents, what would be the fastest path to learn how to get started as a developer on EigenCloud?
I would go to developers.eigencloud.xyz, and then from there you have everything that you need. We have a free tier for everything, so you can get started using our TE product for free. You can get started using Eigen AI for free. We have all of the commands for getting started with the CLIs and all of the SDKs and everything like that. So developers.eigencloud.xyz, that should kind of give you everything you need to know.
Excellent. And we're reaching the end of our time. I like this podcast short and snappy. But if there's something else that we haven't mentioned and that you want to bring up now, now's the time. Any alpha that you can leak?
For me, I would say not really. I mean, Niraj, I'm not sure if you want to chime in.
Yeah, I do have another question. So, do EigenLayer support securing AVS with DeFi LP tokens? Because it can increase the utilization of those DeFi assets while also securing the AVSs. If not, then why?
AVSs can decide which tokens that they would like to enable for their AVS. So it's kind of completely up to them. It's completely permissionless to enable any new ERC20s. It takes like maybe 30, 45 seconds just running, one transaction.
Right on.
That's awesome. Yeah.
Okay, well, thank you so much, Nader. It has been awesome to have you here running us through EigenCloud. It seems like it is built on EigenLayer, at least part of it, or based on the idea of EigenLayer. It builds on the the vision of EigenLayer, of creating these building blocks for people to build apps that are verifiable and secure, so they don't have to worry about all of the complexities of having the security of a blockchain. And I think you've explained it wonderfully. And thank you so much for coming.
Thank you for having me. I enjoyed it.